arrangement of this. It's a little bit interactive, but you cannot actually interact with the Sage object behind. Like you cannot modify the graph and then go back to Sage and do something with it. And the plot we had before, we can also not use a ray tracer and just plot it as like a 3JS WebGL thing, and then we can play a little bit and try to understand what's going on. There's something which I think was mentioned briefly in the initial talk, which are called interacts. So you can define a function that takes one or several variables in a certain range, 0 to 31, and then you can plot something or do anything that produces output. You just print something or whatever, and then you put add interact on top of that, and then you get like a little slider, and you can move it around and see what happens for different values of n. So this is nice. This is fun to play with. There is you can even, instead of interact, put animate in front of this, and then it takes a while, but it will generate a little video. Right. So this is an animated GIF generated from these plots. So it's just a picture file. You can put it on your homepage, and it's going to work without a video player. And you can change. You can make it faster, or you can do more stuff with it. Yeah, here's an interact that uses 2 variables. So it shows you a balanced tree. I'm not entirely sure what that means, but it's some sort of tree with and has 2 parameters, and you can like move them around and then see what happens. And I don't know, you can do like your computation instead of just showing something. All right, interacts are really fun. There's a very nice gallery with interacts in many different areas, and then people have built fun stuff with interacts, where you can explore these vector fields or whatever this might be, and can get pretty graphics of stuff. All right. So it is a little bit interactive. You can interact with it, but you cannot feed what you do back into Sage. So Sage won't really know. Yeah, it's not really dynamic. It's also a little bit slow, like you see when I move and it's really simple things I do, and it still has like a little bit of a delay, so it could be a bit faster, and it could be really more interactive. What do I mean with more interactive? Let me give you an example. So typically what we mean is Jupyter Widgets, which is a technology. So here's an example of a Jupyter widget. It's not built into Sage. It's from a package that is in addition to Sage. It's a package that works with surfaces. So this is a surface. You can imagine that opposite sides are glued in this octagon. So you get like some complicated surface. And you can interact with it. You can change the gluing. You can just use a different arrangement of the same object if you want. It's the same surface, just glued in a slightly different way. And so now you can actually interact with this, because you can get stuff out. So you can ask it for a path, and then you can actually draw a path in the surface. Whatever, like this path. And now this is an object in Sage, and I can actually get some representation in the triangulation of this path. And basically, what I'm trying to talk about is I would like to see more things like this, where you can really do parts of your research on a graphical interface. In Sage itself, to my knowledge, there's nothing like this, or very little. There is a project called Sage Explorer, which is an interactive widget, which you can check out. I'm going to upload this notebook. It's going to be on the wiki page of the Sage Days if you want to check these things out. And there's also Sage Combinat widgets, which I don't know anything about, but it's a widget. It does something with combinatorics, I guess. Why are widgets nice? Well, we've already seen you can interact with them. You can feed things back into Sage. What's also really nice is they work in Jupyter, of course. They work in Jupyter Lab. They work in Jupyter Book to some extent, like if you build them correctly. So you can basically create like a static homepage or documentation page for your project where you have interactive widgets, which is cool. If you want to host a widget on your homepage, say, that actually does real computation in the backend, that calls into Sage to do stuff, there's a pretty secure way of doing this, which is called Voila, which I'm not going to talk about, but it's fun. It's a great project. So if you want to do that, you should check it out. The only drawback I know about widgets at the moment is that, unfortunately, CoCalc does not fully support them. There is a way to make widgets work in CoCalc, but it's not in the standard interface that you see when you use CoCalc. All right. Yeah. Say it again. Ah. Oh, that's weird. Okay, I didn't know that. I usually don't use Jupyter Lab, so Jupyter Lab is different from the notebook. In the backend, it's very different actually, so I'm not surprised. Yeah. No, that's part of the problem, right? You cannot do anything with this. It's just a picture. Yeah.
So what's the relationship between Python, Jupyter, and Sage? So Jupyter is built on Python.
Yes. Yes.
Sage is also built on Python, but Sage, how does Sage talk to Jupyter? I'm just asking if one can sort of import all the Jupyter widgets into Sage.
Yeah. So Sage is written in Python. Jupyter is written half in Python, half in JavaScript. Jupyter gives you these notebooks, and you can run what's called a kernel in these Jupyter notebooks. And one kernel, you know, is Python, so you can run Python code. This kernel I'm using here is Sage, so you can run Sage. And there's like an interface where they talk to each other. Historically, I think the idea of these notebooks was kind of invented in the surroundings of the Sage Math community a long time ago. But by now, we are just using this Jupyter stuff, which is really good. Should this answer the question or not really?
So, I just wanted to understand if that manifold, that octagon example you gave can be quickly imported into Sage.
This is running Sage.
Oh, this is running.
This is Sage. Yeah, this is Sage. This is just not in the standard distribution of Sage. So if you install Sage, this package, which is called IPyVue flatsurf, is not installed. You have to install it. It's just not a standard package of Sage. That's what I meant. It is running completely in Sage, and it's using Sage all over the place. Yeah.
So you can do some interactive things which are inbuilt in Jupyter.
Yes, we're gonna do that right now. Okay. Okay, people wanted to do something with this graph here interactively, so let's actually try to do that. So let's build a Jupyter widget to do something with this graph. Let me see. Okay. Gonna move this here. This over there. The sizes have changed for some reason. Okay. Okay, let me see if I can turn this around without breaking everything, so I can write. Okay, that seems to work. So we want to build a widget. So how does a widget work? Well, a widget is some code in Python, in Sage, and some code in the browser. Let's talk about the stuff in Python first. So we have a graph, of course, and now we want to represent this graph visually. So we kind of can think of this as sort of a state machine, where we have some initial state where we have our graph. Let's draw it like this. So let's take a graph, has like 3 vertices, and some edges. Let's say these 3 edges. And well, how do we represent such a graph? We probably need some state to represent this. So there's going to be, let's say we're going to have vertices. Is this big enough? Yeah, I guess. Otherwise, please let me know. We're just going to number them. So we have vertices 1, 2, 3. And then we have edges. So the edges, maybe just a list of source target, or just pairs of the vertices that they're connecting, 1, 2, 1, 3, 2, 3. And then we also need this layout, right? We want this to be visible like this. So we probably, let's call it positions. So positions going to be a mapping assigning to each vertex its x and y coordinates. So whatever. Let's say vertex 1 is at 0, 0, vertex 2 is at 1, 1, and vertex 3 is at 2, 0. So that's the state that describes this mental model we have of this graph in this moment. So of course, initially there's like some sage object, let's call it G, and we use this object to initialize our graph and build this model. Now we want to interact with it, so I don't know, what do you want to do? Let's do something very easy first. We want to be able to delete a vertex. So we're going to click on a vertex, like say right click on a vertex to delete it. So we're going to say add right click. That's right. So when we click right, we want to delete it. What does it mean to delete a vertex? Well, we need to do some stuff, right? We need to change the vertices down there. We need to remove the edges that are connected to this vertex, and we need to remove this vertex from the positions. What else could we be doing? We could move it around, yeah. I'm going to skip that one because I need a lot more state, because I kind of need to introduce like a camera position, basically. And it's annoying to implement, and I'll talk about it at the end, how to do it, because it's very easy if you don't actually implement it. What else can we do? We could just click somewhere outside of the graph to have it relay out itself. So say we have a big graph, we deleted some vertices, and then we might want to compute a new automatic layout that makes more sense. So if we click right again, but now not on a vertex, but somewhere else, we leave the vertices and the edges alone, but we change the positions. What else? We could want to, like in the other widget, like in the other visualization we've seen, we could want to drag around the vertices. Right. So, okay. So technically, what we're going to do is we're going to say when you do a mouse down, when you click on a vertex, when the mouse cursor goes down, we go into a new state, and in this state, whoop, now it's green for some reason. I guess because I picked green. In this new state, we get the same kind of picture, but now one vertex is selected. And then we can drag it around. So when the mouse moves, we change its position. And when the mouse goes up again, we're done. We save the new position and display it as we did before.
That's what I meant by moving.
Say it again?
That's what I meant when I said move.
Oh, that's what you said when moving. Okay, so I thought you meant like drag the entire picture, because that's a bit more complicated. So we kind of need a. Say it again? No, the edges are just which vertices are connected. So we want to drag the vertex, but leaving the edges intact. We're just going to modify the position, exactly. Yeah, just the visual layout. But we need like to keep track of which one is selected. So we need, let's call it dragged, which, for example, would be the vertex number 2. Yeah. Yeah, just by moving the vertices closer together, that's going to shrink an edge.
Is there a method for changing the position?
In a graph, yeah, it's set pos. Yeah. Okay, so that's roughly like a tiny widget that is already useful and does more than what's currently in there. Now this is kind of the idealized model. Now you have to do this in the website, right? So you need like visualization of this stuff, like display of the stuff. So we're going to use SVG, Scalable Vector Graphics, which is some way in a browser to display pictures. So we kind of need a way to go from our idealized picture to an SVG. With some content. And then, well, now of course, whenever something happens to our picture, we need to modify our SVG, right? So we need all this stuff to also modify the SVG. Let's add one more feature, just for the purpose of showing that it can make this more and more complex over time. Let's say we want to show vertices differently depending on their degree, on the number of edges they have. Maybe we want to make them bigger, or maybe we want to show, whatever, right? I mean, you can imagine. So we're going to add degrees in here, which is just a mapping that assigns to each vertex its degree. And now you see like a problem of this approach, kind of, because I added something and I thought like, I want this feature. And now I need to go through all these operations and figure out whether degrees is affected by them. Turns out only up here I need it. Okay. So that's the plan, that's the widget. Now, if you've done any web programming before, or if you ever tried to make a homepage for yourself, in particular if you already programmed 10 years ago, that probably sounds pretty reasonable to you. However, technically in 2011, some people realized that this is not a very good idea. So they started producing very nice web frameworks that are called Reactive Web Frameworks. So this was invented at the same time in 2011 at Facebook, where they invented React, and at a project called Ember.js, where they built Ember.js. And what does this mean? Well, what you get by using such a framework is you don't need to do any of this. You also don't need to do any of this. And you don't need to do any of this. So the picture has become much easier. How does this work? Well, if you use a reactive framework, let's talk about this bottom part. You define rules how to go from your idealized model to the visualization. But you don't have to define how this thing changes over time. So whenever your model changes, the system is going to make sure automatically that your visualization adapts. And it's going to do so very efficiently, and in particular, much more efficiently than you could come up with if you write it on your own, most likely, unless you're really good at this. So you should not try to modify your visualization yourself. You just should rely on some framework. So if you ever used jQuery or something like this, basically, please don't do this anymore. You shouldn't do that. Also, if we have dependent state, like these degrees, these systems take care of recomputing the dependent state automatically. So we don't have to actually keep track of this. So we can add new features without having to go through the entire code base and checking who needs to know about this new feature. Also, if you have a rule that goes from an external object, like this G, to your model, then you don't actually need to update any of your state yourself. You just update the external object. So when I delete a vertex, I'm just going to delete vertex in Sage. And then it's going to do everything magically for me. So that's the idea. That's our plan. I got like 20, 30 minutes, something like this. So let's try to do it. Say it again? Well, yes, no. No, you don't. It's a good idea to know JavaScript. Let's move this out of the way. So that was kind of the picture I was drawing, roughly. So here's just these. I'm not sure if you've heard of any of these projects. I'm sure you're using them daily. So if you ever use a modern website, you're using, so these are the typical candidates for reactive frameworks these days. Ember.js is kind of not very popular anymore from the initial days. If you ever used Facebook, you used React. If you ever used Jupyter Lab, you used React. If you use Wikipedia these days, you're going to use Vue. If you use Instagram, you're going to use React. So all these things are programmed in these languages. And there's a good reason for that, because it makes the world a much easier place. So I said we had to produce our graph as an SVG. So I'm not sure who of you know how SVGs work. So let's find out how SVGs work. So SVGs are something the browser understands. So we can write them in the browser just to show you how this works. So you say SVG, you say it has a width, it has a height, and then inside this SVG you tell the thing what you want to display. So we're going to need our vertices, which are just going to be circles. They have an x coordinate, they have a y coordinate, they have a radius, and so we see something, they have a color. Right. Here's our vertex. And then we're going to need more of these, of course. And then we're also going to need edges. So for an edge, we're just going to use an SVG command that's called line. It's just a line segment. It has a starting x coordinate. It has a starting y coordinate. It has its final x coordinate and its final y coordinate. And it also has a color, I believe, which is called stroke, if I remember correctly. Let's see. Yeah, here we go, right? So this is a way we can basically build our graphs. Of course, ideally, we probably want to put the line first and then the circle, so the circle hides the line that is intersecting the line. Okay, so let's actually do this. Wait, this is the wrong one. Let's create a new one. Okay, I'm going to use a package that is called ipymu-view. And let's create a widget. It's called a graph editor. Let's get rid of this. And it's going to be a view widget. And we're going to create it from a graph. So let's create one. Let's use some random graph from SageMath. the buckyball, which is, if I'm informed correctly, the graph that you see when you look at a soccer ball. And so we need to tell this thing how to actually render our graph. So let's steal what we had before. Let's take this SVG and put it in here. Oh, wrong thing. Sorry. Put it in here as a starting point. Oops. Got multiple values for template. Yes, I shouldn't put self here. Okay. So now we have our graph in a Jupyter notebook. It's of course not the right graph, it's just the 2 points we drew. So we need the state we talked about earlier. So we need vertices. We're gonna need edges, and we're gonna need these positions. Let's also make the width and the height variables so we can change the size of our widget. So these are going to be, width and height are going to be integers. So how this works is that there is a library in Jupyter that is called tradelets. Not really in Jupyter, but it's a library Jupyter uses. And it allows you in a widget to define variables of a certain type, and then these things are going to get automatically synchronized with the JavaScript code running in the browser. So whenever you change them in JavaScript, the widget is going to know in Python or in Sage Math. When you change them in Sage Math, the JavaScript is going to know.
So, hang on. How do I install IPy?
It's on PyPy. It's not part of Sage.
So I need to go to Python.
Yeah. So, okay. The story about IPyMuView is I wrote this very recently. It's a port of an existing popular package which is called IPyVue. And it ports this package to do 2 things. It uses Vue 3, which is the latest version of Vue. And it lets you run Python code on the front end. So in the browser, you can actually don't have to write JavaScript, but can write Python, which we'll see in a moment.
So, then we want to use Sage graph, right?
Say it again?
No, no. So this is so the Python IPy.
It is? Say it again.
No, no. I want to use my Jupyter here. Maybe I'm not making sense. I'm running the Jupyter notebook.
Yes.
Sage Math.
Yeah, you need to install this package. It's not installed in Sage normally.
Yeah. So what's the best way to install?
So if you're outside of Sage, you can type, depends how you install your Sage. You can probably type sage pip install IPyMuView. The vertices are going to be a list of integers. We always have to add this tag sync to make sure it actually gets sent to the front end. The edges are going to be a list of tuples of integers and integers. And the positions are going to be a dictionary that maps the vertices, which are integers, to tuples of integers, tuples of floats, to the coordinates. Okay, so we need to import some more things. We need float and dict, type error. Int object is not iterable. Right. Okay, here's something that happens a lot when you try to use Sage Math in some basic Python library. Whenever you type a number in Sage Math, like 300, an integer, it is actually not the Python int 300, but it's the element of the integer ring. So many things get confused by this. So you can do an uppercase R to actually tell it, I want the Python int. I don't want the integer ring int. So I think that's a problem. No, it's not a problem. Something else is wrong. Why this character? Yeah. Actually, I don't know. Maybe raw or something. I have no idea. Where's the problem? List tuples. Oh, tuples. It should be tuple. I also need to import that. Okay, here we go. So now we can actually use the state. So let's, for example, say we want to use the width and the height. So in this templating language that defines our visual output, we put, this is very well documented on the Vue Js website. So I'm not going to go into much detail. I kind of refer to this documentation because there's a lot of stuff you can do. But you put like these colons in front, and then it tells it, okay, read this variable. So now I promised you that now the width and height are actually connected. So if I change the width to 10, it's unhappy again because 10 is not an int, it's an integer ring element. If I change to 10R, you see that it's cropped at 10 pixels. I can set it back to 300. So this actually seems to work. So any change I do to width is reflected immediately in my widget. Okay, let's actually draw our graph. So we want a vertex for each vertex, like a circle for each vertex. So we need a for loop. The way you do this is you say v4. We do for each vertex of the vertices. That's again the syntax of the system, vertices, I guess, rather. We want to draw this vertex, so we need to tell it where it's supposed to be. So the x-coordinate we take from the positions of vertex, the first entry, and the y-coordinate we take from the positions of vertex, the second entry. Okay, let's run this. Okay, what just happened? Well, you don't see anything. Now, there might be an error. Let's see. No, that looks okay. What actually happens is, well, we never assigned to our positions or vertices or anything, right? We never told it what these things are. They're all empty lists and empty dictionaries. So let's do that. So initially, we say the vertices are the vertices of the graph. The edges are the edges of the graph. I believe the way graphs edges work is that they are triples, like source, target, and label. We don't want the label, so let's get rid of the label. Okay, let me say labels equals false. And finally, the positions are going to be for each vertex. We want the position of that vertex. So I guess we can say graph get pos for, I guess it's just the right thing, right? Graph get pos. I think it's just graph get pos. We're unhappy about what? We're unhappy about the edges.
Oh, sorry.
Expected a list. Oh, it's an edges view. It's not a list. That's the problem. So we need to turn it into a list. Okay, something happened. Nothing good happened, but something happened. You see something in the corner? That's all our vertices. Because, well, our coordinate system is not very good, right? If I look at this graph, and I do get pos. Oh, graph get pos. Thanks. Well, that's the coordinates, and that's all the top left corner. So that's a bit unfortunate. Let's fix that. Of course, we can be very lazy and just say, well, let's put this in again. Yeah, but then my SVG is going to be very small. Then my SVG is going to be 2 pixels wide. So, yeah. So I'm going to take, let's call this positions, this graph get pos. And then I'm going to take the x coordinate, and just for the sake of the argument, I'm going to scale it up. Vertex and graph vertices. Did I do this right roughly? No. Here we go. Okay. So this is our graph. It's not very interactive yet, but we can already play with it a little bit. So we can say widget. No, we cannot. Anyway. So ideally what we're going to do is we're going to compute a bounding box of our graph and then scale everything to that bounding box. Okay. Since I start a bit late, I think I just want to copy this over from somewhere else, because it's not super exciting how to compute a bounding box. So this thing computes a bounding box. I'm sure you could all figure this out eventually how to do that. And then we have to adapt. So let's get our bounding box and then move things. So actually, let's do this a bit smarter. Let's not iterate over this, but let's iterate over x, comma, y, vertex, x, y. Items. Okay. So what are our coordinates actually? So we take the x coordinate, we subtract we move it to 0. Is that correct? Yeah, I think that works. And then we divide by the width of the bounding box. 0, 0. And then we multiply by the width of our actual SVG picture. Let's see if this works. With height instead. What has happened? Syntax error? Okay. Wait. Something is not closing. This one is not closing. Okay. This worked. So now it's automatically layouting it according to the size of the thing. We need our edges still, so let's add them in the same way. So we get, for each edge, the starting point is the position of the source of the edge, x, the position of the target, no, the source of the edge, y, and similarly for the target. Yeah, so remember that each edge was like a pair source target. See if that worked. Here we go. Here's our graph. Maybe if we just put the lines before the circle, we actually get the circles to be drawn above the lines. Okay. Let's see. Shall we try to delete a vertex, as we had said? So I want to delete a vertex. We want to say that if we right-click on a vertex, it should be deleted. So if we if we click right, then we want to call erase vertex of vertex. Okay, what should erase vertex do? So we have to define this as a callback, so it can be called from JavaScript, from the front end, from the browser. And we're just gonna take our graph and we're gonna delete vertex. So the problem is, if we do this, like this code up here that generates our state, it only runs in the init method in the very beginning when we create the widget. It does not run when the graph changes. So we need this always when the graph changes. So let's write a graph property that returns our graph. And whenever we set the graph, we're going to recompute all these things. So if you haven't used properties before in Python, I mean, maybe just ignore this the syntactic sugar for a moment. We just want, whenever we change the graph, we want this computation to run. So we reset all these state variables. And so we just start by saying self graph is graph. Okay, so now, since I've done this, whenever I change the graph already, it should update my visualization. Whatever. Pick your favorite graph. Right? So that worked. So I can, from the outside, change the state of this widget. And when I right-click, it's going to call this method. So I'm going to update my graph. Let's see if that works. If I right-click, if I manage to hit one, yeah, it goes away. Yeah. And I didn't do any edge erasing anywhere, right? So there's this weird thing, there's this weird pop-up here. So that's just how browsers work. When you right-click, you get a context menu. So you have to tell it that you don't actually want a context menu by adding a .prevent, which prevents the default of the browser. And you also add a .stop for good measure, because we want to have the relayout, and we don't want to have the right-click on the edge, on the vertex, toggle the right-click on the entire picture. Okay, so now I can actually delete stuff. Oh, this didn't work. Click, prevent, stop. Click, right, prevent. That should work. This actually run? Oh, it have to, okay. I only put the prevent on the vertex. So when I click outside of a vertex, I get the regular context menu. Okay, let's fix that. Let's say if we click somewhere right on our entire SVG, then we want to recompute the layout. So let's call relayout. Let's add another callback in here that does the relayouting for us. Takes no parameters. We grab our graph. We gonna change its layout by using setPos. And I believe it's called layout, and you tell it which model to use or something like this. We'll find out in a moment if this works. And then we set our graph again. So now if we right-click, yeah, it relayouts. And if you click a bit crazy, you're sometimes going to delete an edge, yeah, a vertex, because it's going to be under your cursor. Okay, now this is now a functional toy, right? I mean,
I didn't understand what happened when you clicked outside of the vertex.
before, you mean? Or now? Now, what happens?
Yeah, you said, what does right-click outside? You just said this relayout.
Yeah, so I said, so I put a click on the vertex, which erases, and I put a click on the entire picture.
What does that do?
It calls relayout. Does this? Relayout is this method I wrote here. I just wrote.
Yeah, what does it do? I didn't understand.
It sets the positions. So it sets our.
Oh,
of the graph,
Okay, so
of the Sage graph. So this actually changes. So this is my graph, and the corresponding object in Sage, I can ask for it, widget graph, and I can plot it, for example, in Sage normally, right? Right. And if I right-click, I call set pos on this object. So now the positions have changed in this graph.
In that, in some random way.
No, it uses the Spring layout algorithm. So sorry, yeah, it's not random. It uses like some, I'm not sure, like you have to read the documentation. I don't know how it works, but I guess it just emulates the edges as like springs and then tries to minimize the energy or something.
So there's no relation between where you click and what it does.
No. But I could do that. We could add that, but at the moment it just does like something random in that sense. Okay. There's one tiny thing I want to show, and then I'm just going to skip fast forward to the final thing, and so you get an idea that not much more code is needed to make this much more complicated or complex. Let's say this should actually work. Let's make this a bit more obvious by just changing the order of these two. So if I have my widget, let's delete this, don't need it anymore. And I change the graph I'm displaying. Widget graph is graphs. What is a complicated graph? This one, I guess. I think it needs a parameter. 3, 4. Yeah. That's the boring parameter. That's the interesting parameter. Yeah. Okay. What is strange if you look at this? So I have this original graph, and now I change it, and you're going to notice a certain flicker. Maybe. It's a bit hard to see maybe on the projector. Yeah. What's happening here is that when I'm updating these variables, they get sent one by one to the browser. So first I send the new positions, then I send the new vertices, then I send the new edges. So the problem is that sometimes the system might get confused because now there is positions for vertices that don't exist, or there might be vertices but they have no position yet, right? So if you want things to update in sync, you can say withhold sync, and then everything that happens in this block updates at once. So that's like an important trick to get rid of strange bugs that you get when things are not in sync. Okay. So basically now what is missing? The main thing that is missing is dragging around vertices. Now I could do it in the same way. I could do like a mouse down, mouse up, mouse move handler, and then move around my positions. The problem is these handlers, I mean, I want this to have like 60 frames per second, right? I want this to be really nice and fast. But then this handler is going to fire 60 times per second, and 60 times per second, like Sage Math graph library is going to do stuff, and we're going to take the graph from the browser, send it back to Sage, unpack it, build a Sage object, do stuff, send it back. It might just work, but if the graph gets bigger and bigger, you come into trouble. So when you want to do very nice visual things, you might have to write code that actually runs on the browser and not in Sage, not in Python, on the back end. So how does this work? The way I would recommend to do this is to learn a little bit about Vue Js, which I think is a very nice framework and relatively easy to learn, and just write this part in a proper Vue component. It is basically documented at this package how to do that. You can, however, actually use Python code in the browser. So this is super experimental stuff, so I would expect this to break in lots of weird ways. What happens is, let me show you. So this is the kind of the final product. This code has not gotten much longer. It's basically the same. What we've seen before, there's now this dragged function that is triggered when you stop dragging something, so we actually update our graph representation. That's it. And we changed our template, so now it's referring to an external component, the graph editor frontend. Now, this graph editor frontend is defined here, and it reads its source code, in this case from a .vue file. This Vue file has 2 lines of code, I'm going to show you in a second. And basically it reads its entire source code from this Python file. So this Python file is sent to the browser and evaluated on the browser. So the browser downloads a build of Python for the browser, starts Python in JavaScript. And I mean, this is all a bit crazy, but it works surprisingly well. And there's problems, of course, but for this example, it works really well. Let me first show you what it looks like in the end, the final result. So we have our graph. We can hopefully click on vertices and drag them around. And it's smooth, I mean, it looks smooth. And I also added a JavaScript library that does animations, which is just 2 lines of code, but it's like super fancy. So now it does, like, when it relayouts, it actually moves it smoothly. And because it uses this reactive approach, while it moves around, you can still delete vertices. And these kinds of things, right? You can still, like, it's a bit hard to do, but if you move and then hit a vertex in flight, let me slow it down a bit, then it's easier. But it's not going to break. And if you try to write this just with basic JavaScript and basic HTML manipulation, basically this is a case you're probably not going to get right? While the thing is moving, if you erase stuff, it's going to fly in your face usually. So let me show you how that code looks like. Say it again? Yeah, it still does that. Oh, it doesn't do edge deleting yet, but it would be very easy to add, right? I mean, yeah, it's very easy to add. It's just the same story again. Did I copy this URL? No, I did not. So to open this, I'm going to use JupyterLab to show you what's in these files. Say it again? Yeah, sure. Yeah, it's all the same. It's all, like, it's very easy to extend this now. Okay, first of all, I'm going to show you this tiny bit of Vue Js code. This one. Okay. Basically, this code exists because I want this animation library, which is called Green Socks, GSAP. And I need this animation library to move it into Python, and I need this tiny bit of JavaScript to make this happen. If you don't want animations, you don't need any JavaScript at all in this example. Now here's the implementation of the front end. It's basically what we had, just of some things now have moved to the front end. There is our template, which is exactly the same we had, just there's like a mouse up handler, there's a mouse move handler, there's like a few more events now we're taking care of. And it's just Python. So it uses the API of Vue Js, which is you define a setup function that defines your state. So in this case, here's, for example, this dragged state. So this dragged state, this variable, that is the vertex number that you're dragging right now. This has there's no reason why this should live in Python on SageMath, right? I mean, we don't need to know what you're dragging at the moment. Only the browser needs to know what you're dragging at the moment. So you define it here. There's this updating the positions. This is this animation part. Kind of ignore it, but you see that it's not rocket science. I mean, like, it's just a few lines of code. So this does this entire animation business. When you click right, we send a relayout event back to the server. When you click right on a vertex, we send a raise vertex event back to the server. When you drag, we set this dragged variable. When you stop to drag, we send a dragged event to the server and set this variable to none. And what is that? Right, and while you're dragging, we update the position of our vertices. And that's all there is to it. Okay, again, this part is super experimental. And it's a bit annoying to debug because you don't have a real Python. So the Python runs, like you have to look at the JavaScript like at the browser console, and there's going to be Python exceptions and JavaScript exceptions and all kinds of stuff. If it's simple enough what you're trying to do, it might work very well. But there might be things that actually don't work. But so let me finish with saying, if somebody wants to try this out, I would be very, very excited to help. In particular, to write some documentation for this package while I'm doing that, and fix more bugs. In particular, this Python part, I imagine there's lots of bugs in there still. All right. What are your questions? What do you mean the thing you would, I mean, yeah, sure. I mean, you just need to define, so basically it's the same story you have here, where you write one function that takes your SageMath object and extracts the visual information. So if you can do that, then you're basically done. So you say you click somewhere, and then you have this call back into Sage, change your differential equation object, and then it will call this setter again, and then the visual things will update. Yeah. So now I slowed it down a bit. Oh, I did not apparently manage to slow it down. I thought I slowed it down. Why not? I'm in the right. Oh, I was in the wrong version. Okay. So now I can actually delete stuff in flight. And of course, the layout does not change, right? I mean, it has decided already about the layout, so it's not going to relay out without this vertex. You have to just, I mean, you have to click and then click again outside and it relayouts without this vertex. So at the moment, I think this Python in the browser stuff is too unstable to put it into Sage, maybe. Yeah, it would be easy. I mean, it's a pure Python package. It's very small, actually. So also this entire, so really the hard work here is done by Vue Js, which is an amazing library, and it's done by this Pyodide project, which builds CPython for the browser. And then on top of that, this is just a few hundred lines of code. It's like it's a really small project, like even though it does these things.
And would it work from Emacs?
What do you mean?
I'm using Sage only from Emacs. So I know that there is some sort of Widget tree.
Oh, inside Emacs.
No, it's not inside. It goes browser. Yeah. So unless you open browser, that does things there.
So if you can see Jupyter widgets in Emacs in some way, then you can also see this widget. This is just a regular IPy widget. This is like any other IPy widget. Yeah. So one little disclaimer, I'm hopefully going to fix this today, is right now this does not work in JupyterLab just because one URL is wrong. So it's like a super trivial bug. But it's loading Vue Js from a URL that is wrong, and then it's just like not found, and it fails. But it works nice in a notebook.